Today we will discuss the concept of point of intersection of two lines. So here we are given the equation of two lines L1 and L2. So the L1 is x minus 4 by 1, y plus 3 by minus 4 and z plus 1 by 7. And the line L2 is x minus 1 by 2, y plus 1 by minus 3 and z plus 10 by 8, right? So here suppose this is line L1 and this is line L2, and we have to find the point of intersection of these two lines, and at the same time we have to first show that these two lines intersect, right? So what are intersecting lines? So intersecting lines are those lines which are coplanar, and the shortest distance between two intersecting lines is 0, right? But here we are not going to use that method of shortest distance, and here we will solve this problem by some other method, and let us see what is that method. So we have to show that these two lines are intersecting. So here we will introduce the parameter say lambda, and here we will introduce the parameter mu. Now we will find the coordinates of the general point, coordinates of general point on the two lines, right? General point on the lines, So from here we see that the coordinates of the general point are x equal to lambda plus 4, y is equal to minus 4 lambda minus 3, and z is equal to 7 lambda minus 1. So these are the coordinates of the general point on this line L1, and let us find the coordinates of the general point on the line L2. So this is x equal to 2 mu plus 1, y is equal to minus 3 mu minus 1, and z is equal to 8 mu minus 10, right? Now for some value of lambda and mu, these coordinates must coincide, right? Then only we can say that the two lines intersect, right? So for some value of lambda and mu, these two general points must coincide, and let us say that lambda plus 4 is equal to 2 mu plus 1, then minus 4 lambda minus 3 is equal to minus 3 mu minus 1, and here we have 7 lambda minus 1 is equal to 8 mu minus 10, right? Now we will simplify it, and we will form three linear equations in two variables, that is in lambda and mu. So we have lambda minus 2 mu is equal to minus 3, and here we have minus 4 lambda plus 3 mu is equal to 2, and here we have 7 lambda minus 8 mu is equal to minus 9, right? Now here we have three linear equations. Now what we will do? Now we will solve any two equations, and we will find the values of lambda and mu from those two equations, and we will substitute those values of lambda and mu in third equation, and if the third equation is satisfied, then we can say that the two lines intersect. Now here I am taking equation 1 and 2, right? So let us take equation 1 and 2, and let us multiply equation 1 by 3. We will solve these two equations by the method of elimination. So multiplying it by 3, so we have 3 lambda minus 6 mu equal to minus 9, and here we will multiply it by 2. 2 4s are 8 lambda, 2 3s are 6 mu is equal to 2 2s are 4. Now if we add these two equations, we get these two get cancelled, and here we have minus 5 lambda, and here we have minus 9 plus 4, that is equal to minus 5, and lambda is equal to 1. Right? Now substituting this value of lambda in equation 1, we get 1 minus 2 mu is equal to minus 3, and minus 2 mu is equal to minus 3 minus 1. Taking this plus 1 to this side, we have minus 4 here, so mu is equal to 2. So we have obtained the value of lambda as 1 and mu as 2, and now we will substitute this value in equation 3. Now if this equation is satisfied, we can say that the two lines intersect. So let us substitute here. So we have 7 lambda minus 8 mu is equal to 7 times 1 minus 8 times 2, and here we have 7 minus 16, and this is equal to minus 9, and which is same as minus 9, right? So this shows that the third equation is satisfied, and hence these two lines intersect. Clear? Now in order to find the coordinates, the point of intersection of these two lines, we can substitute the value of mu here, or lambda in L1. So here we have x, y, z. So x is the value of mu is 2, so here we have 2 times 2 plus 1. Y is minus 3 times 2 minus 1, and z is 8 times 2 minus 10. So this is 5, this is minus 7, and this is 8 to the 16 minus 10, that is 6. So the point of intersection of these two lines is 5 minus 7 and 6, and this is how we solve this problem. Now there is one more method to show that these two lines intersect. So let us discuss that method. Here the equation of the line L1 is given in Cartesian form, and also the equation of line L2 is given in Cartesian form. So let us convert these two equations in the vector form, and the vector form of the line is vector r, and here we have vector a plus lambda times vector b. So converting this equation, we get vector r is equal to 4i cap minus 3j cap minus k cap plus lambda times I cap minus 4j cap plus 7k cap. And similarly, the vector equation of this line is I cap minus j cap minus 10k cap plus mu, and here we have 2i cap minus 3j cap plus 8k cap, right? So here this line passes through the point 4 comma minus 3 comma minus 1, 4 comma minus 3 comma minus 1, and the direction ratios of this line are 1, minus 4 and 7, or in other words we can say that this line is parallel to this vector, and in the second line this line passes through the point 1 comma minus 1 comma minus 10, and the DRs are 2 comma minus 3 comma 8, and in other words, this line L2 is parallel to this vector, that is 2I cap minus 3J cap plus 8K cap. Now we know that if two lines intersect, then the shortest distance between them is 0, and here we have the condition A2 minus A1 dot B1 cross B2 should be 0. It means this is the condition for two lines to intersect, right? So the dot product of these two vectors should be 0. Now where here this is A1, this is A2 vector, and here this is B1 and this is B2, right? Now this is vector A1, this is vector A2. Let us find the difference between vector A2 and vector A1. So here we have substituted the values. So we have minus 3I cap, I minus 4I is minus 3I. Then we have plus 2J cap, and then we have minus, this is plus K and this is minus 10K. So we have minus 9K cap, right? Now we have to find B1 cross B2. So this can be obtained by evaluating this determinant, and this is vector B1, and vector B1 has components 1, minus 4 and 7, and here the components of B2 vector are 2, minus 3 and 8, right? Now if we evaluate this determinant, we have I cap, then this is minus 32 plus 21, then we have minus J cap, then we have 8 minus 14, and then we have K cap, and here we have minus 3 and plus 8, right? Now this is 11 minus 11 I cap, and this is plus 6J cap, and here we have plus 5K cap, right? Now after getting the values of A2 vector minus A1 vector as this vector, and B1 cross B2, we have this vector. Now we will find the value of this expression. So A2 minus A1 dot B1 cross B2 is equal to see, here we have the the coefficient of I cap is minus 3, so here we have minus 3 times minus 11, and then we have 2 times of 6, here we have 6, 2 times 6, and then we have minus 9 times 5, right? Now this is minus minus plus 33, this is 12, 2 6 are 12, then we have 45, and see, this is 45 minus 45 is equal to 0, right? So therefore these two lines intersect. So this is also a method for proving two lines to intersect, and how to find the coordinates of their point of intersection by taking here lambda and mu and finding out the general point. Now let us take this problem. Here we have to show that the lines L1 and L2 intersect, and also find the point of intersection. So here the line L1 is given as x minus 1 by 2, y minus 2 by 3 equal to z minus 3 by 4. Let us take the parameter as lambda. and here we have the line L2, x minus 4 by 5, y minus 1 by 2 equal to z equal to mu, right? Now we can show that these two lines intersect by the method of computing this expression, and then we can show that the dot product of these two vectors is 0. But here I am not using this method, so we will take the usual method and we will find the general point on these two lines. So from L1, the coordinates of the general point are x is equal to 2 lambda plus 1, y is 3 lambda plus 2, and z is 4 lambda plus 3. And in L2, the coordinates of the general point are 5 mu plus 4, and here y is 2 mu plus 1, and z is equal to mu, right? Now we know that these are the coordinates of general point on line L1. This is the general point on line L2, and for some value of lambda and mu, these two coordinates must coincide, or these two coordinates must represent a same point P, right? For some value of lambda and mu. And what is that value of lambda and mu? We will solve the three linear equations. How? We will equate these two coordinates and we get 2 lambda plus 1 is equal to 5 mu plus 4. Here we have 3 lambda plus 2 is equal to 2 mu plus 1, and 4 lambda plus 3 is equal to mu, right? Now if we solve it, we get 2 lambda minus 5 mu is equal to 3. This is equation 1, and from here we have 3 lambda minus 2 mu equal to minus 1. This is second equation, and the third equation is 4 lambda plus mu, it is minus mu is equal to minus 3, and this is third equation, right? Now what we will do, we will solve any two equations and get the value of lambda and mu. Then we will substitute that value of lambda and mu in equation 3. If the equation 3 is satisfied, then it shows that the two lines intersect. So let us take equation 1 and 2, right? So here again we will solve these two equations by method of elimination. So multiplying equation 1 by 3, right? So we have 3 2s are 6 lambda, 3 5s are 15 mu, and 3 3s are 9, and multiplying the second equation by 2. So we have 6 lambda here we have 4 mu, and here we have minus 2, right? Now we will subtract these two equations. So here we have plus, here we have minus, here we have plus, here we have plus. So these two get cancelled. Here we have minus 11 mu, and here we have 11, and the value of mu is 11 by minus 11, that is minus 1. And if we substitute this value of mu in equation 1, we get 2 lambda minus 5 times minus 1 is equal to 3. So 2 lambda is equal to 3. This is plus 5, and here taking it to this side we have minus 5. This is minus 2, and the value of lambda is minus 2 by 2, that is equal to minus 1. So therefore we have obtained the value of lambda as minus 1 and mu as minus 1. And let us see whether these two values of lambda and mu satisfy equation 3. So the equation 3, the left hand side of equation 3 is 4 lambda minus mu. So we have 4 times minus 1 here, and here we have minus 1. So we have minus 4 plus 1, that is equal to minus 3, and C, here also we have minus 3. So therefore lambda equal to minus 1 and mu equal to minus 1 satisfy equation 3. Hence we can say that these two lines intersect. Now in order to find out the point of intersection, we will substitute the value of lambda and mu in any of these two coordinates. So let us substitute here. So we get x is equal to 5 times minus 1 plus 4, y is 2 times minus 1 plus 1, and z is equal to minus 1. So we have minus 5 plus 4, that is minus 1, and this is minus 2 plus 1, that is minus 1, and here we have minus 1. So therefore the coordinates of this point P are minus 1 comma minus 1 comma minus 1, right?